We will work with expanded form. The key to being successful with expanded form is knowing your place value columns. What you're going to do is take the value of each one of the digits in a number and kind of split them apart, I guess is the best way to describe it. So we're going to start with the 3. The 3 is in the ones place, so its value would be 3 times 1 because the 3 is in the ones place. We will combine that value with the value of the 2. The 2 is in the tenths place. So we multiply 2 times 1/10 because that is the column that the 2 is in. It doesn't matter to me if you use the fraction form for 1/10 or the decimal form for 1/10 in the value. So you could use either one of those to represent the value of the 2. Plus, we have the 1 is in the hundredths place. So we would do 2 times 1/100th. And again, if you prefer to use the decimal values, I would accept that as well in place, the decimal 100th in place of the fraction 100th. So that would be expanded form. It's taking the value of each digit and adding it to each other. If we were to multiply all of these out, we would end up with the original number we began with. So if we get to the second example, what we have to keep in mind is zeros have no value. So in expanded form, zeros are not included. So we will skip this 0 and we'll go to the 4. The 4 is in the tenths place. So in expanded form, we would say its value is 4 times 1/10. And for the rest of these examples, you are welcome to use the decimal form instead of the fraction form for these. The next digit is a 0, so we don't do that one. And we will go to the 6. The 6 is in the thousandths place, so its value would be 6 times 1/1000th. If we move to our last example here, the 2 is in the tens place. It is in front of the decimal. It is in the tens place, so its value is 2 times 10. The 7 is in the ones place, so its value would be 1 times 7. The next digit is a 0, so we skip it, and we move to the next digit, which is a 2. The 2 is in the hundredths place, so its value is 2 times 100th. And that's expanded form. Now we will talk about comparing decimals. Comparing is we want to determine whether the decimals are greater than each other, less than each other, or possibly equal in value. Before we start to even look at each place value column to compare them one at a time, we would want to make sure that our decimals have the same number of decimal places. What I mean by that is both of these digits has a 2 or a 1 digit number in front of the decimal, so we want to look behind the decimal. This decimal here has 2 places behind the decimal. This one also has 2 places behind the decimal. So we can compare them as they are. No extra steps are needed. So we look, both of them have a 2 in the ones place. But if we notice, this one has, on the left, has a 5 in the tenths place, and this one has a 3 in the tenths place. So the greater value would be the one with the 5 in the tenths place. So this, we can say 2 and 54 hundredths is greater than 2 and 36 hundredths. If we think of this as money, I probably wouldn't have to have even explained all of that, because you know that $2.54 is greater than $2.36. Remember, anytime thinking about decimals as money values makes the problem easier for you, please think of it that way. In our second example here, though, we notice that both of the numbers have 1 digit in front of the decimal, but this decimal number on the left, 9 and 13 hundredths, has 2 decimal places, where 9 and 3/10 has only 1 decimal place. So before we can start comparing, we need to make sure that we even this out. Now, how would we even out 2 decimal places in one number with 1 decimal place in the other? Remember, we've discussed that we can add zeros behind decimal numbers without changing the value. We can add as many as we need. So all we need, though, in this case is one extra place so that we balance out 2 places on the left, 2 places on the right. Now we're ready to compare 9 and 13 hundredths compared to 9 and 30 hundredths. They both have a 9 in front of the decimal. But if we look behind the decimal, this one is 13 hundredths. This one is 30 hundredths. 30 is more than 13, sorry. So this time we need the less than sign. If you notice on these first 2 examples, I took just a little bit different twist as we started comparing columns. In both of them, we looked at what was in front of the decimal first to compare, because if that's different, then we don't have to go any farther. All of those were the same though. In this first example up here, I looked at each column separately. The 5 in the 10th place separate from the 3 in the 10th place, and compared it that way. In the second example, once we balanced out the decimals so that they both had 2 decimal places, I compared them as a whole unit behind the decimal, as 13 hundredths compared to 30 hundredths. So whichever method is easier for you, please follow. If we look at the third example, both of our numbers have 0 in front of the decimal, so we need to look at the decimal places. On the left, we have 2 in 53 hundredths. In the right, we have 3 places in 530 thousandths. Since the left side has 1 fewer decimal places, we know we can add a decimal place behind it, and we insert a 0 without changing the value. And we now see that they're exactly the same. In our last example, both numbers have a 6 in front of the decimal. So we need to look behind the decimal. On the number on the left, 6 and 315 thousandths, we have 3 decimal places. In the number on the right, 6 and 5 tenths, we have only 1 decimal place. To balance that out, we would have to add 2 more decimal places to 6 and 5 tenths. We would add zeros in those 2 decimal places, so we now have 6 and 500 thousandths. When we compare now, we have on the left 315 thousandths, and on the right we have 500 thousandths. 500 thousandths would be greater, so we can say that 6 and 315 thousandths is less than 6 and 500 thousandths. Now when we order numbers from least to greatest or greatest to least, we'll follow the same kind of a system. We want to balance out each of the decimal numbers so that they all have the same number of decimal places. I recommend lining the decimals up as they are in the problem, but line them up vertically, one under the other, making sure the decimal points and all of the place value columns are in line. So you notice I'm carefully lining up the 2's, the decimal points, and then the tenths, hundredths, and thousandths column. When I do that, I notice that this number, 2 and 9 hundredths, has 1 fewer decimal places than the rest. So what would I do with this extra place? Well, what we've been doing, we'll add a 0 when we balance them all out. Now I notice I want to go from least to greatest, so I want to make sure that when I write my answer, I put the lowest value number first. They all have 2's in the 1's place, so I'm looking behind the decimal here at the decimal places to order them. And I'm just realizing, I'm sorry, I accidentally wrote the wrong number here. This should have been a 1. So then that means that this here should have been a 1. I apologize for that. So now we can put the numbers in order. We have 7 thousandths, 714 thousandths, 90 thousandths, and 17 thousandths. 7 is the lowest of those values, so 2 and 7 thousandths would go first. This one would be first. Second would be the 17 thousandths, then 90 thousandths, then 714 thousandths. Keep in mind, we're paying attention to what's back here behind the decimal because all of their whole number places are the same. If any of these places in front of the decimal would be different, we would use that to order them first, before moving behind the decimal. So I'm just going to continue writing them in their correct order. And on 2 9/100ths, whether you keep it in its original form as it was here in the problem, or you write it with the 0 behind it, doesn't matter. Remember that 0 doesn't change the value of the number. Okay. We're going to do least to greatest again. I'm going to line them up vertically, making sure that we keep all of the decimal places in line. Okay, here we go. We have a problem now that we have one of the digits in front of the decimals different from the others. Since we're going least to greatest, and we have zeros in 3 of them, but a 1 in 1 of them, we know this one has to be greater, because 1 is greater than 0. So we already know this one's going first. I'm sorry, this one's going last, since we're going least to greatest. This one's going last in our list. We need to now look at the other 3 decimals that are listed. Since the first one, 678 thousandths, has 3 decimal places, we need to balance out the other 2. We'll change 58 hundredths to 580 thousandths, and we'll change 7 tenths to 700 thousandths. Now we can compare them. Keep in mind, we already have this one taken care of. We're not going to worry about that one. We'll look at these other 3. We have 678 thousandths, 580 thousandths, 700 thousandths. The smallest of those would be 580 thousandths. So we will go here. Again, we can either use the number with the extra digit of the 0, or we can use it in its original form. Next would be 678 thousandths. Third would be 7 tenths, or 700 thousandths. And the greatest, we said, we rolled that one out first, was 1 in 678 thousandths. This last one is the same idea, just we're going in an opposite order. This time we're going greatest to least. It's important that we always pay attention to those directions. I'm going to first line up all of my numbers so that the decimal places and place value columns all line up. As I'm writing, I notice that all 4 numbers have a 4 in the ones place. So that column won't help me place anything in order. I'm looking at the decimal places now. The longest decimal we have is 4 803 thousandths because it has 3 decimal places. So we will balance out the other ones and make them into 3-digit decimals as well. So we're going to change 8 hundredths into 80 thousandths. We'll change 5 tenths into 500 thousandths, and we'll change this 18 hundredths into 180 thousandths. Again, all the front numbers are the same. That's not going to help us order, so we're going to concentrate back here. And again, we're going greatest to least. So that would mean 4 803 thousandths would be the greatest. Working our way down to 4 5 tenths or 4 500 thousandths. You can write it either way. Next would be 4 18 hundredths or 4 180 thousandths, as is written here. And the smallest would be 4 8 hundredths or 4 80 thousandths if you keep it in that form.